Hi there, welcome to this video tutorial on Spearman's rank correlation coefficient. Now, to demonstrate this, let's just suppose we had, say, 4 people, let's say they're called A, B, C and D, and they're doing a competition. It doesn't really matter what competition they're doing, but let's say they're awarded marks by 2 judges. And we've got Judge X here and Judge Y here. And the marks they award to A are 4 and 5 respectively, and to B 3 and 4, and so on. Now suppose we want to see how well the judges agree with one another in the way they mark the 4 contestants here, A, B, C and D. One way we could do this is to rank the marks by calling it Rx and Ry. And when we award ranks, let's say we give the highest mark first rank. So for instance, for Judge X, he awarded A the top mark. So that person is ranked 1. And he awarded B 3 marks, the next lowest rank, let's say 2. And then for C, that's going to be 3, and for D, that's going to be 4. When it comes to our second judge, Judge Y here, then how does he rank A, B, C and D? Well, he gives top marks for A, even though it was different to what Judge X gave. He awards A the first place, top rank, and then 4 marks for B, so that's second rank, and 2 marks for C, that's third rank, and finally 1 mark for D, the 4th rank. Now can you see that although they've awarded different marks at times, they still agree perfectly with who they think is the best and who they think is the worst. We have what is called perfect agreement here. If we were to draw the marks awarded by Judge X and Judge Y on a grid, it would look something like this. You can see that A was awarded 4 from X and 5 from Y. And I've plotted the other marks given to B, C and D here. So what we've got here then is perfect agreement between the 2 judges. Now suppose the judges had awarded marks like this to A, B, C and D, as you can see in the table. Do they agree this time? Well, let's just have a look at the rankings for X and for Y. When we look at how Judge X ranked A, you can see this was given the lowest mark. In fact, Judge X ranked D with the highest, so we'll put that as 1. And then C got the next lowest marks, so that would be rank 2, B the next one down, 3, and A was the lowest, so we'll put that as 4. Whereas for Judge Y, the ranking here, he ranked A as being the best, so we'll put that as 1, and then B was the second with 4 marks, C the third with 1 mark, and finally D got the lowest mark, 0 here, so that'd be ranked 4th. And can you see with this, we've got 2 totally opposite sets of agreement. One judge thinks A is the best, that's Judge Y, whereas Judge X thinks A is the worst. And it happens like that all the way through here. And if we're to look at the scatter diagram, it will look something like this. What we have is perfect disagreement. One person thinks one person is good, whilst the other person thinks they're the worst. Perfect disagreement. And have a look at the type of scatter diagram that we've got for perfect agreement when you compare it to perfect disagreement. Do you notice how for perfect agreement it's always going up from one to the next point, whereas for perfect disagreement it's always coming down as we move from left to right? Now clearly we're not going to always have situations where we have perfect agreement or perfect disagreement. We might have something like this. This time I've got 5 contestants, A, B, C, D and E, and the judges award them the following marks. Now if we were to draw a scatter diagram, then it looks something like this. Notice how this time we don't seem to have perfect agreement or even perfect disagreement. So we need some kind of measure that can tell us what kind of agreement or disagreement we've got. And this is where Spearman's rank correlation coefficient comes in. Spearman's rank correlation coefficient is given by this formula here. We denote it as R with a little subscript S here. It's equal to 1 minus 6 times the sum of all the squares of the differences in the ranks. And it's all divided by the number of observations n multiplied by n squared minus 1. And this particular formula gives a value of RS between -1 and 1. I'll show you how it works. We'll do it with this one up here. You rank your values just like I've done here, and then we need to work out what the difference is in the ranking. In other words, D. So for this table here, when it comes to working out D, it'll just be 1 minus 1, so that's going to be 0, 2 minus 2, 0, and so on. It's all going to be zeros. And then we create another column, D squared. So if we square each of the D's, we're still going to get 0 all the way down. And so when it comes to working out what the sum of D squared is going to be, it's just going to be 0. So for Spearman's rank correlation coefficient, RS, according to the formula, it's going to be 1 minus 6 times the sum of the D squareds, which is going to be 0, all divided by n, which is 4 values. So we're going to have 4 times 4 squared minus 1. Well, because the top is 0, all of this fraction here is going to be 0, so what we get is that RS equals 1. So for perfect agreement, this formula comes out at 1. Let's look what it comes out at when we do this one, which we've seen is perfect disagreement. If we work out the value of D for each of these pairs of observations, D here will be 4 take away 1, which is 3. 3 take away 2, 1. 2 take away 3, minus 1. And 1 take away 4, minus 3. Next we square all these values, and then it eliminates all the negatives that we get. So 3 squared is 9, 1 squared is 1, minus 1 squared is 1, and minus 3 squared is 9. So when it comes to working out Spearman's rank correlation coefficient, it's going to be now 1 minus 6 times the sum of all the D squareds. Well, that comes to 20. And so we've got 6 times 20, all divided by 4 times 4 squared minus 1. Remember, n is 4 in this example. And if you work this out, this fraction comes to 2. And so you end up with RS is 1 minus 2, which comes to minus 1. So for perfect disagreement, the formula gives us minus 1. So RS, Spearman's rank correlation coefficient, is designed to go between -1 and 1. Now if you've got a value of 0, then this indicates that there is no agreement whatsoever. So we'll just put that down. If you get a value close to 0 though, then there's going to be little agreement if it's positive, or if it's very close to 0 but negative, then there'll be very little disagreement. So what have we got then for this particular table? Well, in this table we've got to take care because we haven't got 4 competitors. We're now up to 5 competitors. Now you might like to even have a go at this yourself and see what Spearman's rank correlation coefficient is going to be. So if that's the case, just give you a moment to pause the video. Okay, welcome back then if you had a go. Well, first of all, what we've got to do is find out what the ranks of the marks are. So for Judge X, the judge gave the highest marks to C here, so that will be ranked 1. Next was E, so that's going to be 2. After that was B, so that's going to be 3. Next was A, so that's 4. And then finally we've got D, so that's going to be 5. And for Judge Y, what was the ranking here? Well, 5 marks were awarded to C, so that's going to be 1. 4 marks were given to B, so that's 2. And then 3 to E, so that's going to be 3. And then we've got 2 for D, so that's the 4th place there. And finally A at the bottom there, so that's going to be 5. So let's work out our differences now between the ranks. So we get 4 take away 5, which is -1, 3 take away 2, which is 1, then 1 take away 1 is 0, 5 take away 4 is 1, 2 take away 3 is -1. And then we just need to square these. So we've got -1 squared is 1, 1 squared is 1, 0 squared is 0, 1 squared is 1, and -1 squared is also 1. So Spearman's rank correlation coefficient then is going to be 1 minus 6 times the sum of this column here, which is going to be 4. So it's 6 times 4. Remember now though we've got 5 observations here, so therefore n is going to be 5. So it'll be 5 times 5 squared minus 1. Now if you work out this fraction, it comes to 1/5 or 0.2. So 1 minus 0.2 just gives us 0.8. Now what we've got here is a value tending towards 1, positive value, so it's tending towards some form of positive agreement, perfect agreement. So I'm going to say that what we've got here is some agreement then between the judges. Now when you're ranking the values, you don't have to give the highest value first rank. You can give the lowest value the first rank, as long as you're consistent between both ranking columns. Try it. Try it, say, for this one, instead of giving the 5s here first rank, just reverse it. Give the lowest mark then first rank. So in this example, for this mark here, for Judge X, just give D the first rank. And then check out what you get. You should arrive at exactly the same value. So it doesn't matter then how you decide to rank your values, as long as you're consistent across both columns. Another point that's well worth mentioning is that if you get a value of 1, it doesn't mean the same as what we had when we were doing linear correlation. It doesn't mean that the points are necessarily in a straight line, as you can see from this example here. You get 1 when you go from left to right and you're always going up to the next value, never back down again. You get -1 when you're going from left to right and you're always going down to the next point. Notice how in this one, as we move left to right from point to point, we go down and then we go up and then we go down and then we go up again here. So if R turns out to be 1 or -1, it does not imply necessarily perfect linear correlation. Your points aren't necessarily going to be in a perfect line going up for 1 or a perfect line when it's -1. Okay? So I hope that's given you some idea then how we apply Spearman's rank correlation coefficient to each of these tables, the meaning behind it, and as you can see, the types of scatter diagrams that we get with our points. Okay?